Okay, so we're just working with the model of the groundwater flow in the vicinity of Clemson campus, and I put in some points here in Brackett Hall and monitored the flow paths using ModPath. And so one of the things that I was just looking at was how I could make the paths a little more visible. So I went to Particles, and I can change the color of the path lines here. And that makes the red makes the path lines a little more visible. And what we see is that these particles that we put in the vicinity of Brackett Hall, it really depends on just exactly where they are. Groundwater or Brackett Hall appears to be on or very near a groundwater divide, with the particles that are here on the southwest side going down to the southwest and discharging into the Seneca River here in the bottom area, and then a few particles over on the northeast side went up to the north and discharged into this little stream. So there's apparently a groundwater divide right here, and it depends on where the particles start. It makes a big difference actually in where they go. This is actually often a problem because industries are built on the high ground and built near groundwater divides, and so you can imagine that if this was really just a fairly small facility, but if they had one source of contaminants at one end of their building and another on another end, they could indeed have two groundwater plumes that go off in much different directions. And that's actually fairly common. So let's take a look at this in oblique view, and we can spin this around and see what these particle paths look like. So we've got some potential contaminants starting out here. You can see they go vertically downward, and when they reach the bottom of the permeable zone, so this would be the transition zone or maybe some permeable fractures in the top of the rock, then they turn laterally and move laterally, and then they get in the vicinity of the streams and they come up and discharge to the stream. So one of the things that we would be interested in, of course, is what this path is, because wells along this path could potentially be contaminated. And we'd also be interested in where the contaminants are discharging, because this could be an area that would be vulnerable to exposure to the aquatic ecosystem, or perhaps to people that are in this vicinity. So what I want you to do for your homework is set up a model, much like the one that I've set up here, of the vicinity of Clemson campus, and assume that there are three potential areas that could have released some contaminants to the groundwater. A source in the vicinity of Brackett Hall, Lowry Hall, and McAdams Hall. Three areas where at least some of you have your home department. And so let's take a look at what plumes from these three areas would look like. And I want you to go and do the analysis, and then you can make an image of this, copy and paste it into Word. And then I'd like you to get out a colored marker and draw out the outlines of the plumes by hand, and then also show on the map the location of the discharge zone. That would be the area that you would go to see if indeed there was a plume discharging there. So go and draw that stuff up by hand. So it's not going to be just a digital output. I want you to get out the marker and put in your own input. And so the details of the assignment are posted. And what I would like you to do is try working through this try working through this exercise. You don't have to do the whole assignment, but try working through this prior to class on Wednesday, and then we'll meet in class on Wednesday and go over questions. We can work through things if you have some difficulties. one thing too, actually, in closing, that I'd like to point out is if we zoom in here, we see the contour that the model has predicted. This is the head contour, and we can see the flow direction going perpendicular to that contour. So this is a gaining stream, and it's flowing in that direction, which is what almost everybody found in the problem that you did back in the early part of the class when you did a 3-point problem. So the model is consistent with those observations. And indeed, one of the things that would be done as a next step after we do just a preliminary model like this and get it going, then we would go and look for field data to calibrate the model so we can be assured that this model will represent the field conditions as accurately as possible.